Hey, this is Brandon Masson, and today I will be explaining my project for ECE 331. So for my project, I decided to talk about microchips because that is a topic that I was interested in learning more about, considering that there's a shortage of them in the world and I've heard so much about them. I wanted to know, maybe not why there's a shortage of them, because that's a different topic, but why are they so important? Like, what is a microchip? So, first of all, I thought a good thing to do for this project would be to try and relate microchips to ECE 331. And in ECE 331, we mainly talked about electronic or discrete circuits with electronic components. This is different from a microchip because a microchip uses integrated circuits. So all the circuits that we looked at in class are electronic circuits because they have some sort of wiring that serves as the conductor that allows the current to flow from one component to the other. In a microchip, the conductor is the silicon chip. This means that there's no use for any wiring or anything like that. So you can pack on much more components onto a silicon chip without worrying about bulky wiring that will take up space. So these components on the microchips, the transistors, they get very small. So we're talking nanometers. I think the smallest transistor is like 2 nanometers, which means in a microchip the size of my fingernail, you can have 50 billion transistors. So basically, the smaller these components are, the more that you can fit onto a single chip. And the more that you can pack onto a single chip, the more powerful, more computing power that you have. So because these chips are very small and very efficient, and they have a lot of computing power, they're very important for modern electronics and a lot of our electronic devices. So that's why the demand for them is so high and will continue to be so high. And that is why microchips are very important. And just one final thing aside, since these components are already so small and they seem to continue to keep getting smaller, we have to ask ourselves, like, how small can these components become? And I think that is inevitably going to be a huge challenge for engineers in the future, because we are going to be testing the limitations of our technology and how small these components can become. So we have to ask ourselves, is there going to be a limitation or a hard cap on our computing power in the future? That's about it. See ya.